Hello everyone and welcome back to Nunley Math. Thank you so much for joining us here today. I'm your host Aaron Nunley. Excited to have you with us as we begin a brief unit on polynomials. We'll take today and do a brief introduction to those. We'll spend our next lesson talking about adding and subtracting those, and then we'll spend several days talking about multiplying polynomials. We don't really talk about division of polynomials at this level. Typically that's considered by most people to be an Algebra 2 topic at this point, but that's neither here nor there for us today. So, a brief introduction to polynomials. You should already know from our exponents unit that a monomial is a mathematical expression in the form ax to the k power, where k is a positive exponent. That's a fairly formal definition of a monomial. I've given you some examples to refresh your memory. 5x squared is considered to be a monomial because 5 would be in the a position. You have your x and you have an exponent that is positive. We would consider 3a squared b cubed to be a monomial because it does have the 3 in the a position. It does have a variable to a positive exponent, and there's a second variable to a positive exponent as well. That x to the k pattern, that variable to an exponent, can be repeated as often as we want as long as this is just one long string of multiplication. Lastly, we also consider constants like the number 7 to be a monomial because it can be written in the form 7x to the 0 power. Now, when we talk about monomials, we often break them down into their pieces. Of course, we have the variable, which in this case is x. The exponent listed here as k is sometimes called the degree. Occasionally, people refer to it as the power. And of course, the number in the front here, a, is referred to as a coefficient. So if I were to give you this monomial at the bottom, 5x to the 4th, and I were to make reference to the degree of the exponent, I'm asking you to look at this right here, the degree of the monomial. The 4 is the degree for this monomial. The 5 is, of course, the coefficient. When we talk about polynomials, polynomials are either a monomial or the sum of several monomials. They're either a monomial or the sum of several monomials. Remember, monomials are that ax to the k pattern. Within that pattern or that term or that unit, there's nothing but multiplication, which allows us to apply a lot of properties we couldn't do otherwise. But when we begin to stick in addition signs or subtraction signs, and actually to some degree division signs, we lose the ability to do some of the things we can do with a monomial. So a polynomial is either just that monomial or it's several of them strung together by addition. We do give polynomials names based on two criteria. There's the degree of the polynomial. There's also the number of terms in the polynomial. Take, for example, this 5 here. A 5 is a monomial. Remember, if we wanted to fit it to that ax to the k power form, this would be 5 times x to the 0, because x to the 0 is a 1, and 5 times 1 would just be 5. Anything that's to the 0 power is considered to be a constant monomial. A constant monomial. This one is considered to be constant because anything to the 0 power is 1. 1 times 5 is 5. So no matter what value you plug in for x, this will never change. It is constant. Take a look at this second one. The second one has two monomials. You've got this 4x at the beginning, and then since it's supposed to be the sum of several monomials, this would be plus negative 10 x to the 0 power. Two monomials strung together. This may look familiar to you because in our functions unit, we dealt a lot with things like f of x equals 4x minus 10. This was a type of function or a function family we worked within. It was called a linear function. For the exact same reason, this polynomial is considered to be a linear polynomial. Anytime the highest degree monomial or highest degree term is x to the first power, it's going to be linear. Take a look at this example down here. You have 1, 2, 3 monomials. 2x squared, 5x, and -7. Three different monomials. Remember that -7 is the same as -7x to the 0. So this monomial right here, this first one, is the highest degree monomial, x to the second power. This, of course, is x to the first power. This is x to the 0 power. When you look at this all together, it should look familiar to you from our functions unit. We often wrote it like this. This type of function had a special name. It's a quadratic function. Because this is a quadratic function, for the very same reason, this is a quadratic polynomial. The next one down, you have x to the third, x squared, x to the first, and x to the 0. There are 4 terms, or 4 monomials. The highest one, of course, is that x to the third power. Just like in our functions unit, we could write it out like this. That makes this a cubic polynomial, just like this was a cubic function. Now I'm going to continue on down. The next one has 5 monomials. You have x to the fourth, x to the third, x squared, x to the first, x to the 0. The highest one of those is x to the fourth. We did not really do fourth degree function, so I didn't bother to write one of those in for you. But I will tell you that anytime your highest degree term is to the fourth power, we call it quartic. Now, I remember that because there's 4 quarters in a dollar, or 4 quarts in a gallon, or, yeah, that should be sufficient. But yeah, this x to the fourth is where it derives its name. Once you get bigger than that, like 2x to the fifth, after that, we really don't come up with creative names for it. I'm sure if you look deeply enough, someone has created one out there. Most of the time after that, we refer to those just as 5th degree, 6th degree, 7th degree, and so on and so forth. This is naming by degree. X to the 0 power is constant, x to the first is linear, x to the second is quadratic, x to the third is cubic, x to the fourth is quartic, x to the fifth is a 5th degree polynomial. The next thing we can do is we can name them based on the number of terms. Notice that this is a single monomial. As a result, we just call this a, oops, there we go. This is a single monomial, hence we just call it a monomial. Look at this 4x minus 10. We said before that 4x minus 10 is actually 2 monomials strung together. It's a 4x and it's a -10. Since there are 2 of them, we refer to it as a binomial, just like a bicycle has 2 wheels. The next one has 3 monomials in it, the 2x squared, the 5x, and the -7, or -7x to the 0. Since there are 3, we call it a trinomial. And then once we get bigger than that, this one has 4, we just start referring to them as polynomials. Poly meaning many. We really don't want to spend a lot of time memorizing names for polynomials that don't appear a whole lot. I did go ahead and underline these just for sheer joy of underlining. That was a 5-term polynomial. And this is, of course, a 6-term polynomial. One other term you need to know is the leading coefficient is the coefficient of the first term when it's written in standard form. We'll talk about standard form in just a second. Standard form is when the polynomial is arranged from highest degree to lowest. Notice over here I put my x to the 5th before my x to the 4th, before my x to the 3rd, before my x squared, before my x to the 1st, before my x to the 0. The coefficients are the 15, the -2, the 9, the -1, the 3, and this one right here, this 2, is called the leading coefficient because it comes first when we put these in order. So we can mix and match our names to name lots and lots of different types of polynomials. For example, notice that if I'm looking at the degree, this is an x to the 3rd term, this is a x to the 0 term, x to the 3rd is the higher of the two, so we would call it cubic. Then we would look at the number of terms. This one has the 9x cubed and the 5x 0, that is 2 terms, making this into a cubic binomial. Can you name this one? That's a quadratic binomial. Quadratic because it's x to the 2nd, binomial because there are 2 of them. How about this one? This is a cubic because x to the third is the highest exponent, and is a trinomial because there are 1, 2, 3 monomials. That one. That's a linear monomial. Notice x to the first makes it linear. The fact there's only one of them and no plus signs makes it a monomial. How about that one? Remember, if it's x to the 7th power, we just name it based on the exponent itself. So this is 7th degree, and there is only one monomial, so we call it a monomial. How about that? This is a 5th degree, because x to the 5th is highest, polynomial. Remember, any bigger or longer than a trinomial, we don't bother naming it. This has 1, 2, 3, 4, 5 monomials. 5 monomials. We just call it a polynomial. How about that? This one's actually a little bit tricky. Notice that this is just a monomial because there's not a string of these connected by plus signs. As a result, when I look at this, I want to find the degree of this entire monomial. We do that by adding the exponents together. This is considered to be an 8th degree monomial. 8th degree monomial. Remember, the degree of the polynomial is always the sum of the exponents of the highest degree term. Remember, we don't add all the exponents together, just the exponents within a single term. So that if I gave you more complex polynomials like this, and I ask you, what is the name for this polynomial? I would look just over here at this 4x squared y squared, and I would ask myself, what is the sum of the exponents? I would then look over here and say 11x squared y. What is the sum of the exponents? And then I look over here and say 6x to the first. What is the sum of the exponents? Well, this is a 4th degree monomial. This is a 3rd degree because you have the 2 and the 1. This is a 1st degree. That makes this a 4th degree, since that's the highest one, trinomial. You might want to try this on your own. Maybe pause the video, take a look. I have 1, 2, 3, 4 terms, or 4 monomials. This is a 7th degree monomial, 2nd degree monomial, 1st degree monomial, and this is a 0 degree monomial. The highest is 7. We don't have a special name for 7, so we would just call it a 7th degree. And since there's more than 3 of them, polynomial. It's not bad, right? A little bit of terminology to familiarize yourself with, but it shouldn't be too awfully hard for you. Now, sometimes people will talk to you about your polynomial, and it's helpful to know some terminology so that when they speak of your polynomial, you can understand what they're saying. For example, here's a fairly long polynomial. This is a 5th degree polynomial. Look at the x to the 5th. I could ask you, what is the coefficient of the cubic term in this polynomial? A lot of vocabulary there, but it's not too terribly difficult of a concept. The cubic term, cubic you'll remember means x to the 3rd power. So what I'm asking you is, in this monomial right here, the cubic monomial, what is the coefficient? Well, that's the number in front, so the coefficient is a 5. How about this? What is the coefficient of the constant term? The constant term. Well, remember the constant term is the x to the 0 term, which is this one over here. Your coefficient is a 1. What's the coefficient of the 5th degree term? Hopefully you realize it's 6. What's the coefficient of the quadratic term? Remember, quadratic refers to x squared. In this case, the x squared does not have anything written in front of it, but remember, I can always put a times 1 anytime I want to, so the coefficient is 1. What's the coefficient of the linear term? The linear term is the x to the 1st power, which means the coefficient is this -7. Remember, it has to be -7 because a polynomial is defined as the sum, which means I have to make this into plus negative. Anybody know the coefficient of the quartic term? The quartic term? This one's actually a little bit tricky because quartic refers to x to the 4th power. There is no x to the 4th power written here, which means this should be 6x to the 5th plus 0x to the 4th plus 5x cubed. Your coefficient is 0. I think these are fun. You may or may not agree with that, but I think they're kind of enjoyable. I'll give you another one of these to try it again. Try this on your own. What is the coefficient of the cubic term? The cubic term. Did you get -3? Notice x to the third power. The number in front's the -3. How about this one? The coefficient of the constant term. Remember the constant term is the x to the 0 power? Well, that's over here. Here's x to the first. It should be plus no constants. The coefficient of the quadratic term. Quadratic refers to x squared, which means the coefficient is the number in front, which is 5. The coefficient of the linear term. Remember the linear one is x to the first power. That's this one right here, x to the first power. Notice there's no number in front, which means it's a times 1. Since there's a minus sign, this would be -1. How about the coefficient of the quartic term? That's x to the fourth power. Hopefully you came up with the 8. I've got one more of these for you. This one's a little different, Notice that I have x to the fourth and y squared. I've got multiple variables here. What do you think the coefficient of the cubic term is? Notice cubic term refers to the third power. That's this one right here. X squared and y to the first is a total of 3. So your coefficient is a 5. But the sixth degree term, do you see that one? That's over here. 4 and 2 make 6. Your coefficient is 8. How about the quadratic term? Quadratic term, remember, means something to the second power. That's this one here. Notice x to the first, y to the first. That's a total of 2. It is -1. What's the coefficient of the linear term? That's a 1. Notice 1x to the first power. And the coefficient of the quartic term, well, the quartic term is this one right here. So you get -3. Now, it is important to know that polynomials should always be arranged so that the term with the highest degree is listed first. Notice in this problem, I have 3x to the first power plus 4x squared minus 2. This is a second degree monomial. This is a first degree monomial. This is a 0 degree monomial. So I need to rearrange these and put them first, or put the x squared first. Notice now it goes from second to first to 0. This would be considered standard form. Now, it is important to realize that when you start rearranging these things, if there's a minus sign in front of a number, that minus sign has to stay with the number because this should be plus negative when you start rearranging. How about that one? Can you do that one on your own? If you want to try it, just pause the video. I'm going to go ahead and go. I've got 4x to the fifth, 7x cubed, squared, first power, 0 power. Again, pause the video if you want to try this on your own. I have x to the fifth minus 7x to the third plus 5x squared plus 1x plus 11. Again, pause the video if you want to try this one on your own. Here's what I have. Notice, by the way, that there is a tie for the quadratics. Notice you have x to the fourth. The quartic term is first, followed by the cubic term, but then you've got these two quadratic terms in here together. Whenever that happens, what we're going to do is we're going to arrange them alphabetically unless we are told otherwise. We're going to do this alphabetically unless we're told otherwise. So in the alphabet, the letter X comes before Y, so we would put the X first. Here's one for you. Notice in this one, you have x cubed, y to the fourth. That is a 7th degree term. Here you have x squared and y. That is a 3rd degree term. And then you have the x to the 6th by itself is a 6th degree term. In order, by degree, you would have your 7th degree term first, your 6th degree term second, and your x squared y, your 3rd degree term third. 7, 6, and 3. Now, there are occasions where we want to write these not just in standard form, but we want to write them to emphasize a particular variable. For example, you could be asked to arrange this in order by x. If that was the case, if that's the way the question was asked, you would not list this in the same order. Because if we were to look just at the x's, x to the 6th is the highest degree x, followed by x to the 3rd, followed by x squared. If you're asked to arrange these by x, you would arrange it this way. 1x to the 6th plus 10x cubed y to the 4th minus 5x squared y. Be very careful when you're checking directions to make sure you know what they're asking you to do. Now, they could have asked you to arrange this by y as well. If we had arranged it by y, the y to the 4th would have been first, the y would have been second, and the y to the 0 would have been third. Last one, you may want to pause the video and try this on your own. Notice this is a 4th degree term, a 5th degree term, and a 4th degree term. This is the first time we've seen a tie with multiple variables. Remember, when we do ties, we typically write those alphabetically, which means our answer would look like this. The 5th degree term is first because it's the highest. Then when I go down here and see this 4th degree and this 4th degree, I ask myself, which of these alphabetically comes first? It's going to be x squared. Remember, if you wrote this out, this is x, x, y, y, or x, y, 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 the x would come first in the dictionary. Some of my students prefer to say that if you get to where you're at a tie, you just check the letter that's first in the alphabet to see which one's higher. I think that works out pretty well. As always, thank you so much for taking time to join us here today. We do appreciate it. Please leave us a comment in the comment section. Make sure you hit the like button, subscribe, and turn on those notifications so you don't miss any of the algebra coming out of math or Nunley Math. Thank you so much. Take care of yourselves. Bye-bye.